Alright, we are going to look at question number 38. We have got a person who did an experiment. There is a setup X as well as Y. So technically, because of this, I know there's a comparison going on. He placed equal amount, so that tells me there's a fair test going on. Same temperature also into two glass of beakers, X and Y. Now straight away when I study the picture, I need to look out for evidence. Okay, so the evidence that I can spot immediately over here is they seem to look different in terms of size. So immediately what comes to my mind, I have to think of exposed surface area. Alright, so he placed both beakers on the table in the room temperature 25. So this is the graph that was being shown. Now at 15 minutes, you do find that the temperature difference is quite a big gap. So it seems that Y has a lower temperature compared to X, even at the same time. So the question was temperature, why is it slower than the setup? So we are going to look at in terms of the differences, alright, which is in terms of the size. So we figure out it's a comparison. We need some kind of a comparison statement inside. So since it's a 1 mark question, we're going to start it off by saying or talking about the evidence. So from the evidence, we can see from the picture, in fact the picture tells us that the one in setup Y, so setup, was it setup Y? Yeah, setup Y has a higher exposed surface area. Okay, so how do you check whether your evidence is there or not? Making sure that your comparison is there, making sure the powerful word, the exposed surface area is there. Okay, then we moved on. We talk about the results. So in this case, the results will be with a higher exposed surface area. We need to talk about in terms of heat transfer or heat loss, right? Because we need to explain why the temperature is dropping. So we should talk something about heat loss. But of course, I always say when it comes to heat energy, you do want to talk about the direction. So the heat loss to which direction, to where? So in this case, we will take it as the heat loss to the surrounding will be faster. Okay, so just before I end it off, I will need to do a check. I have got the comparison word here, higher. I have got the pair of comparison faster. So that completes the whole question. Okay, now we move on to B. Give a reason why the temperature of water stops decreasing. Alright, now in real life, if you have something icy water, you place it in the room temperature, you know after a while it will remain in that room temperature, right? And if you put a drink in the hot sun, under the hot sun, you also find that that water somehow becomes warmer. It seems to go to the temperature where the surrounding is. So the same idea over here, why does it stop decreasing? Obviously it must have returned to what the room temperature was, right? So if something was being mentioned about room temperature, you are fine. So why if the water has returned to its room temperature? With that, you are fine, okay? Because so how do you mark? You will be looking at least this word, room temperature. Alright, and if there's going to be a verb, it will be returned. It's a verb, an action. Okay, now we go on to part C. Now part C, we often say this, usually part B, part C, part D, the answers are connected. The ideas are almost the same. So if you look at it, you will find that, hey, in fact, the idea here is also going to be like what part A is on exposed surface area. How do I know? Because the size tells me so. Alright, so he finished his tea. He says this friend asked him to pour the tea over to the saucer instead. Sometimes you see that in coffee shops, the uncles do that. They will pour the drinks to the saucer, but they are actually doing something scientific as well. How does pouring help? So we will have 1 mark again. Let's do the evidence. Same thing, from the saucer we can see that there is a higher exposed surface area for the tea, right, when it's on it. And because of that, the result of that will be same idea. Basically that tea will lose heat to the surrounding faster. So you see the answer is actually quite similar, or in fact the same as part A. Sometimes it will be, sometimes it may not be the same. So in this case, the idea at least is the same. So I highlighted in blue because I found a pair of comparison words. Okay, now another idea again is still on heat transfer, I'm sure, because it's under part ABCD connected. So Ben bought a cup of hot tea. There's a piece of cardboard. This is quite interesting. Those who actually have bought drinks from Starbucks and there's this shop called Boost where they blended all the fruit juice, you find that they actually provide this cardboard over here for good reasons. And why is that so? Hot tea without getting burnt. Okay, of course you as a scientist here, you got to explain why is that so. And they gave a hint. They gave a very, very strong hint here. What did they say? Air trapped inside. They're very nice. They told you there's air trapped inside. They want you to talk about in terms of that direction. So immediately I can point out the evidence already. But bearing in mind this is 2 marks, so I have got my evidence 1 and results 1. I've got my evidence 2 and my results 2. So check along with me as we watch the video. Now evidence, immediately from the picture I know there's a layer of air. Okay, so hopefully you are good lawyers. You have spotted this evidence directly from the picture, from the sentence also. Now what does this layer of air do? We know that it is a poor conductor of heat. So this has to be mentioned because of the air and it is a poor conductor of heat. Alright, something along that line. And the result of this causes a second evidence to happen. This will cause your heat transfer, or I can say heat loss. Same thing, heat loss, but this time round I do want to also say the direction, right? Remember, we always want to talk about where is the heat loss or heat gain from or to. So heat loss to the hands. In this case, we are focusing on the directions to the hands. Why? Because the question is interested in how you can apply, since it's about the hands that's holding it. Heat loss to the hands will be slower. So what happened? Ben, we answer back the question, right? So the result is always answer back the question. Ben will not feel how should I put it? Going back to a solution, maybe something like will not feel hot from the tea, or Ben's hands will not feel hot from the tea. Okay, so something along that line for the result. The final result always answers back to the problem, that's to say. Okay, so with that, I come to the end of question number 38. Watch the next clip for question 39.